Good afternoon, esteemed guests, professors, and all my dear colleagues. You were saying something, sir? I am Srimay Chakraborty, Senior Research Fellow, Geological Studies Unit, ISI Kolkata, and on behalf of our unit and our institute, I welcome you to the Professor Sarbani Patranabis Deb Memorial Lecture 2023. The Geological Studies Unit at the Indian Statistical Institute, Kolkata, was established with the vision of expanding the role of statistics and fostering a symbiotic relationship with various academic disciplines. GSU's research endeavors encompass tectonics, structural geology, sedimentology, geochemistry, metamorphic petrology, paleobiodiversity, and biotic evolution to reconstruct the Earth's geological history and paleoclimate. Professor Sarbani Patranabis Deb has been associated with the Indian Statistical Institute for nearly 2 decades, since she was not only a faculty member, but also had been a PhD student in our unit. Her dedication towards the Institute showed in every little effort she made. She not only encouraged the students to excel in the academic field, but also made sure that we looked after our health and our well-being. There is one incident I'd like to share. A few years ago, they bought an apartment very close to the institute, and we were all present one day, and she told us that if anybody ever needs a place to stay, because a lot of us commute for very long hours, she said, if you ever need a place to stay over here that is close to the institute, just ask me, and my place is at your disposal. It's these little small things, these efforts she made, that made her so different. Professor Deb was an integral part of not only our unit, but also this institute. Her multidisciplinary skills and research work in the field of geology made her an indispensable part of the scientific community. She was always an active participant in every important project and decision, and never let her illness stand in the way of her stellar academic career. She not only helped our students, but she also helped the people who were on the same path as her. She never let anything stop her in her way. We are honored to host the first memorial lecture in her memory. She was a fellow of the West Bengal Academy of Science and Technology, WAST, and we extend our gratitude to WAST for their support in hosting this lecture. Before we begin with the lecture, we request our honored guests, Professor Shivaji Chakraborty, President WAST, and Professor Amit Ghosh, Vice President WAST, and Associate Professor Shilatri Shekhar Das, Head of the Department, Head of the Unit, GSU, to please come to the dais. I request Professor Shilatri Shekhar Das to say a few words to us.
Thank you very much, Sumi. Good afternoon, everybody. On behalf of the Geological Studies Unit, Indian Statistical Institute, I extend a warm welcome to all of you to Professor Sarbani Patranabis Deb Memorial Lecture. It's a great honor for the Geological Studies Unit to host this lecture at ISI Kolkata. My heartfelt gratitude goes to West Bengal Academy of Science and Technology for organizing this event at ISI. Professor Sarbani Patranabis Deb was our esteemed colleague, and we have cherished my memories together. Srimay has eloquently highlighted her remarkable. Once again, I welcome all of you to this lecture. Thank you very much.
Thank you so much, Professor Das. Now I request President of WAST, Professor Shivaji Chakraborty, to say a few words and conduct the meeting.
Warm greetings on behalf of West Bengal Academy of Science and Technology. At the outset, on behalf of the Academy, I convey our sincere thanks and gratitude to the family of Sarbani Patranabis Deb for providing the endowment fund for this lecture our Academy has instituted this year. And this is the inaugural program of this series, which will be held every year in the fond memory of Professor Sarbani Patranabis Deb. As the President of West Bengal Academy, I would like to say a few words about the Academy. There are quite a few very senior academic fellows present here, former presidents and our sectional committee conveners. So for them, maybe it's all known, but there are here quite a few youngsters. So I would like to say only what West Bengal Academy currently does. So primarily, West Bengal Academy tries to promote activities in science and technology, particularly in the state of West Bengal. But here I would like to emphasize that our academy is an academy for West Bengal, but it is not an academy of Bengal. Very clear in that respect. We have, of course, guidelines who could be fellows, but as our name stands, it is West Bengal Academy of Science and Technology. So we try to do something, providing, say, policy directions or something which our state needs, which would be helpful in the coming years in the area of primarily science and technology, but we also include social sciences. So it's not that we are only just physics, chemistry, geology, not like that. The fellowship of West Bengal Academy is competitive. We have a three-stage selection process. The first stage is called for nomination. As you know, it's not based on application, it's only based on nomination. That means only the fellows can nominate somebody. And then this goes to our sectional committee, sectional committee, carrying the intent of, you can say, science and technology. Then our sectional committees go through the nominations and shortlist some out of the nominees that have been proposed that year. Then that goes for the stage 2, which is the peer review. That means those nominations are sent to people who are experts in the domain. And after the peer reviews are obtained, then it goes to the stage 3. That means again it is taken up by the sectional committee. They go through the peer reviews, but finally again, based on their wisdom and judgment, they recommend only a few of them to the Council of West Bengal Academy, and Council is the final decision maker, and they decide finally that who will be elected as fellows every year. Typically, we elect around 30 to slightly more than that per year. Earlier, it was all limited to 30. It is now extended a little bit. But as you know, say 13 sectional committees and maybe 30 fellows, so you can clearly see how competitive it is. And we have to understand that we have all sorts of branches, physics, chemistry, mathematics, geology, biotechnology, medical sciences, and engineering, the entire spectrum of engineering and technology. So we select very best people as our fellows, and therefore this tag, that means FASCT, carries a weight and it adds value to that particular person who is elected as a fellow in different forums. So in future, I would like to see some of you youngsters sitting in front of me as our fellows. Of course, there is another category we have, which is called associates. That means those who are still probably not that mature to become a fellow, but they can be nominated as associate. Again, that follows the same selection procedure I told. But then if the council feels it right, they are elected as associates, and they can remain associate as 5 years or up to the age of 40. And after that, of course, we look forward to have them as our fellows based on their contribution in science and technology. Apart from that, we have 3 endowment lectures. There were 2 already existing, and this year we have started Sarbani Patranabis Deb endowment lecture. So we have altogether 3 endowment lectures, which is conducted every year. Then we have the annual oration, which is always held concurrently with our annual general meeting, typically in the middle of the year. And these are our flagship events, which we conduct every year. In addition to that, we conduct several events. For example, in this year, we have already conducted 2 events. One in the memory of Professor M.S. Swaminathan, who needs no introduction, as you know, the father of Green Revolution. So we conducted a program which was organized in Sister Nivedita University. Then another program was organized in the memory of Professor Dr. C.R. Rao. Again, in Statistical Institute, I don't have to say who is Dr. C.R. Rao. That was also held very recently, and that was held in the auditorium of the Bose Institute in Salt Lake. And now this is the 3rd program in this year we are having. So we also expand in several other directions, and we are trying to now expand our outreach. As a part of that, now West Bengal Academy has started its own YouTube channel. You are most welcome to visit the YouTube channel, and I sincerely request you, all of you, to subscribe to that channel. This particular program currently is presently in live in YouTube channel. So if you have your mobile, just see whether you are getting it. I have got the feedback that it is already live. And so that's also part of our outreach program. We are also trying to come up with some sort of, training programs or workshops for bachelor's or master's level students, not in any subject, but those which are very relevant today, which could help in the career prospects of the young people. There is one in the pipeline in the January, February. We are going to organize. We'll announce it pretty soon. We have a very well-designed website. So just have a look at that in our website, where all our activities, everything is properly disseminated. So these are, in short, what West Bengal Academy presently is doing, but we are trying to grow. We are trying to reach farther. And today, in this hall, I'm very happy that I was just trying to count. I find more than 40 people present. So this is very encouraging attendance. And I sincerely thank all of you, very senior people, younger people, faculty, family members, everybody. Now we are waiting eagerly to listen to our esteemed speakers. So I'm not going to extend any further, waste any further time. Thank you very much for joining in this program, and please join in our future programs too. Thank you. So I have been requested by the compeer to introduce the speaker today. Professor Sanghamitra Ray completed BSc Honors and MSc in Geology from University of Calcutta. She specialized in vertebrate paleontology and was awarded PhD in 2000. Professor Ray was a postdoctoral fellow at the University of Cape Town, South Africa for 3 years from 2000 to 2003. As SRS CSIR from 2003 to 2004, and then joined IIT Kharagpur as a faculty member in 2004. Professor Ray has been teaching different courses on paleontology, stratigraphy, sedimentology, and geostatistics at undergraduate and postgraduate level, and has completed guidance of 5 PhD which have already been awarded, along with many master's advisees and mentored national and international postdoctoral fellows. She has, to her credit, nearly 50 publications, including 3 book chapters, Most of our scientific publications are in international paleontology journals of Q1 ranking. She is member of Society of Vertebrate Paleontology, USA, the Paleontological Association, UK, the Paleontological Society, USA, and of course, Geological Society of India, Bangalore. So we have a very distinguished speaker and we are all eager to listen to her. Thank you once again.
I kindly request Professor Shambhavita Rai to come to the podium.
কপি করতে হবে কারণ তিনটি কোড আছে আমাদের আমি চাই না আমার টপ কপি করে তারপরে তিনটে কোড আছে আমাদের
Second one. I'll request some lights to go off. Otherwise,
Before Professor Rai begins with the lecture, I would request IoT Banerjee to felicitate Professor Shambhavita Rai with a small token.
Is there a pointer? I hope all of you at the last can hear. Is it okay? Thank you, Professor Chakraborty, for your kind words. Now, this is, I'm honored to be called for Sarbani Patranabis Deb Memorial Lecture. I have known Sarbani from 1989. We have did our post-graduation, graduation together, and we joined both of us in the same year to ISI Kolkata to do our PhD. So it's the first picture is from our BSc fieldwork, which took place in Tukur district, Karnataka. And this is Sarbani. I am somewhere in the over here. And then in the course of our Okay, let me have pointer. Yeah, I'll use the pointer. I will change this. And this, what I thought about when I was approached for this lecture is that I will just discuss a few of the stories that this fossil tells us, and mostly based on the work that has been done at IIT Kharagpur and with joint collaboration with Indian Statistical Institute. So just a little bit of recap. You know that there are many types of fossils, and they can be clubbed together into body fossils. Body fossils are those fossils where the morphology of the animal is preserved, and we also have the trace fossils where the activity of that animal gets preserved. So this body fossils, this body fossils can also be differentiated into macrofossils and microfossils based on their size. Basically, microfossils are those for which we need to have a microscope for its scientific identification. Now, in today's talk, I'll be talking about the macrofossil, I'll be talking about the microfossils, and a little bit on the trace fossils. So what is the application of fossils? I think all of us know that when we are studying with fossils, that means there will be some difficult scientific words that we have to remember. And in our graduation, post-graduation, I think reading or studying paleontology is hampered by those scientific words that we have to remember about fossils. And the main thing about fossils is that the most common thing we do that we look at their taxonomy, that is we give it a classification, we name it, and then we also use it for biostratigraphic correlation. This is what I think all geology students know about. But there is also another very common thing that we do, and that is we also study paleoclimate, deduce paleoclimate using fossils. But today, what I'll be talking about is some of the lesser known studies that is done with the help of fossils. And this is, the first is I'll be talking about taphonomy, which is the process of fossilization, or it gives us the signatures of how after a death of an organism, it turns into a fossil. So this is what I'll be talking about. Next, I'll be talking about paleobiology. Paleobiology based on bone histology, or how to study bone microanatomy, to let us know about what was the biology of that animal, that is, how that animal used to live, how it used to move, what sort of animal it was. And the last thing that I'll be talking about is, from knowing about fossils, from knowing the geology of an area, what do we try to do? What is the ultimate aim? The ultimate aim is to reconstruct the paleo ecosystem that was present there. What sort of interaction the biotop is having with other environment, the physical, the chemical, and even with itself. So these are the three things I thought I will talk about. And to talk about fossils, especially vertebrate fossils, we have to go back to the Gondwana basins. And as we know that there are four major Gondwana basins in peninsular India, and these are these four basins. And from each of these basins, these are highly fossiliferous. And most of these fossils we get from the very diagnostic red mudstone of the different horizons. So how do we collect fossils? Collecting of fossils, it's a laborious work which requires extensive surveying for fossils, not fossils, but surface indicators that will tell us that yes, fossils are present in this area. And ultimately, we go for removal of the overburdened sediments, some using shovels, using whatever type of digging instruments we have with us. And after that, we label these fossils. We sometimes in packets like this, or in many cases, we also plaster jacket them and bring them to the lab and prepare them with the help of by removing the host rock matrices that is present in the fossils. So coming back to the Gondwana basins, I will be focusing on the Triassic fossils, and as we can see that there are 8 Triassic horizons which are highly fossiliferous in terms of vertebrate fossils. And of this, and the relative abundance shows that 72% of the so far whatever vertebrate fossils has been collected, that belongs to the upper Triassic horizons. And when we talk about upper Triassic horizons, we come to the Malady and lower part of the Dharmaram formation of Pranika Godavari basin and the Chiki formation of the Rewa basin, which is in the northern part of Son Mahanadi basin. In terms of Triassic fossils, again, if I look at the different horizons, what I see is that the Chiki and Malady and Dharmaram, they actually form the upper Triassic fossils. And of this, the Chiki has 35% of the total fossils so far, vertebrate fossils so far collected. So my study will be based or focused mainly on the this Chiki formation. And the pictures here shows the fossils of 2 groups of reptiles. One is the phytosaur and the other is the rhynchosaur. So in the next few slides, I will be talking about these phytosaurs and rhynchosaurs. Why? Because these are the most common vertebrate fossils that is known from the late Triassic horizons, not only in India, but globally in most of the countries in many parts of the around the world. Now, this is the geological map of the Chiki formation, and fossils have been collected from many different parts, but I will be concentrating mostly on those fossils that has been collected from these 4 bone beds, and ideally mainly from this part where it is marked as L2, and there is another one which is marked here as L3. And so the first case that we will be discussing is on the how to deduce the taxonomy or how to find out the fossilization pathway of a phytosaur fossil. Now, what is phytosaur? This is an extinct group of carnivorous reptiles, and as I said, they are known from different parts of the world from the upper Triassic horizons, and they are very similar to that of the modern day crocodiles. They look very similar to the modern day crocodiles, and that's why scientists believe that they actually occupied the same ecological niche as the present day crocodiles, mainly the gharials. So from the Tiki formation, what we discovered is a monotaxic bone bed. What is a monotaxic bone bed? That means a bone bed that comprised of only this phytosaur bones. There is no other taxa present in that bone bed. This bone bed is about, it was found in the red mudstone, and it is about 50 square meter in area. And this shows the spatial distribution of those phytosaur bones. Each of the square actually is of area of 1 square meter. So while we were actually collecting these bones, at the same time, this sort of diagram we were drawing it so that we can actually have a pictorial representation of the bone bed. More than 1,000 identified skeletal elements were discovered from this bone bed. And as you can see, these are the different 16 to 25% is the limb bones, that is 16% is vertebrae. These are the different skeletal parts of an phytosaur. And this phytosaur has been named as Colossus techniensis. Why Colossus comes from the word colossus. That means it's one of the largest phytosaurs known globally. And techniensis is in honor of IIT Kharagpur. So that is the Latinized name. And this is the Colossus techniensis. And based on the morphology, based on the relative size, based on the number of paired and unpaired skeletal elements present, we estimated that that bone bed contained the skeletal elements of 21 individuals of phytosaurs. It's not a single individual, but 21 individuals. And when we actually estimated the size, we found that most of them were either juveniles or subadults. So 17 of them were juveniles or subadults. Only 4 of them were of adult size, and the largest individual had an estimated body length of greater than 8 meters. So this was a juvenile dominated phytosaur community that was discovered from the Tiki formation. And to look at the taxonomy, different types of variables, biostratinomic variables, they were measured. One thing what we found is that in most of the limb bones, although the one end of the limb bone is well preserved, the other end is not that well preserved. It's almost as if some sort of decay has happened to this other end. So we started looking at why this has happened. Another feature that we found is that these are very small bones. These small bones were not present in the collection. We could not find a single, maybe 1 or 2 digit bones may be present, where it should have been 34% of the collection. And similarly, the chevrons, which are also very small bones, they are also not present in the collection. So we did a summary of all the taxonomic, this table gives a summary of all the taxonomic observations. These are the variables that were all documented. And what we found is that some of the salient points is that it's a juvenile dominated community. As I said earlier, 90% of the bones were dispersed, but they are in close spatial proximity. But all 3 Buddhist groups are present. They have suffered minimal abrasion. Minimal abrasion means there is almost no transportation, but they had a high weathering stage. High weathering stage means they had a prolonged exposure to weathering. And they also have this calcareous and ferruginous incrustation. So based on these biostratinomic models, we actually proposed, based on these biostratinomic variables, we proposed a model where this phytosaur community was found in one place comprising of juveniles because of parental care that is very evident in the reptiles, in recent time reptiles. Then it is a monotaxic accumulation, and with this monotaxic accumulation, which actually takes into account the juveniles, subadults, and adults, all of them has died together. So what could have been the reason for this mass death? So this is actually what we thought is that this could be a disease-induced mortality, because there are no other evidence to suggest anything else. And I'll come to this point later. Then most of them are preserved upside down. That means if you look at the skull, instead of instead of having a sort of a normal positioning of the skull, most of the skulls are upside down position. Then these are disarticulated, as I said. They are color mottling because of prolonged submergence in waterlogged conditions, and abrasion, absence of abrasion means their site of death is very near or almost the bone bed has formed where this mass grave is, or the bone bed represents a mass grave. And as I said earlier, they show subaerial exposure. So, go next. This is just a picture that I wanted to show you. This is from a paper by Simon Salisbury 2014. And this is the disarticulation that they have actually studied on recent crocodiles, that they have, after the death of the crocodiles, what they do is that this is how their skeleton gets disarticulated. And because they have, after the death, they have floated up, the carcasses are bloated and floated up, they actually get preserved with these are the skulls which are in an upside down position. And this disarticulation pattern very much matches with that of that we found in the bone bed. And that is why we can actually say that yes, this phytosaurs have also undergone post-mortem bloating and floating. Next. Now, what was the possible cause of mass death? This is what actually was, it was a sort of a problem that we were trying to solve, because what could have caused this death, which usually, because if you think about elephant graveyard contains individuals which are all old, which are now all going to die. But when we take into account juveniles present in that graveyard, if we take into account the subadults present in the graveyard, then there has to be some sort of mass death. Now, this mass death could be catastrophic, could be because of flash flood, but we found no geological or sedimentological evidence to suggest that there was a flash flood. Then it could be toxicity from algal blooms. Now, this is again a very common feature we find in present day world. That is because of this algal blooms, there has been mass death of fishes in Mozambique. There has been mass death of Nile crocodiles in the Kruger National Park of South Africa. So this could be a possible reason. But for algal bloom, there has to be some very special climatic conditions, which includes rising temperatures, stagnant, slow moving of water, and sudden changes in weather conditions. Now, whether these were actually present, we are still looking into this. We are looking into this criteria to see whether this is the result, or this is what this algal bloom has resulted in the death of those phytosaurs. And then it could be an epidemic disease that affected the entire community. So to look into this, we actually looked at the bone microanatomy of 18 individuals, and out of this 18 individuals, we found that 8 individuals, including juveniles and adults, they show unusual bone microstructure. And this sort of bone microstructure, which indicates that there was a sort of epidemic bone infection. Now, we do not know that whether this bone infection has resulted in the fatality of the entire community. We are still looking into this aspect. So we are still looking into whether algal bloom has caused this mass mortality or whether this bone infection could have caused the mass mortality. But one thing we can say is that this is the first report around the world and where this sort of epidemic bone infection has been documented. In no other, this sort of bone infection has been documented in many dinosaurs, in many extinct forms, but that has been documented in just one or two individuals, not in 8 of them, and that also covering the entire age spectrum. So this is one aspect of the study that is still going on, and the second one is how to deduce the paleobiology of a rhynchosaur. Now again comes the question, what are rhynchosaurs? Rhynchosaurs are again it's again a type of reptiles, and these are where the phytosaurs were carnivorous. These are actually omnivorous to herbivorous rhynchosaurs, and as you can see, they are very common in the upper Triassic horizons. And we have in India, there are 2 types of rhynchosaurs present. One is Haprodipodon huxley from the Godavari basin, and the other is Haprodipodon tichensis from the Chiki formation. So one thing we saw in case of rhynchosaur is that rhynchosaurs, they have a very characteristic feature. This is the side view of the skull. This is the eye socket. And if you go to the Geology Museum of this institute, you will find a mounted skeleton of rhynchosaur. The most characteristic feature is they have this bone, which is in the front of the skull. It's the snout part of the skull. And what it is, if there are 2 bones like this, they are actually carved. They are beak-like. People call them beak-like bones, that is the premaxillary bone. Now, if you look at the reconstruction of the rhynchosaur skulls in all previous work, what they have done is it visible or should I remove the chair?
Sure.
Go back to So if you look at the reconstruction, everywhere in all previous literature, you will find that this bone is always depicted as naked or exposed. And this was a problem, or this was a idea of research that was first advised by late Professor Tapun Rai Chaudhary, who told me that, Shambhu, why don't you look into the study? Because nowhere in nature we find bones exposed. Because if you look at any animal which is present nowadays, we don't have any exposed bones. We have exposed teeth, but the constituent material of teeth and that of this bone is complete. It's a bone, it's not a teeth material. So with this in view, when Sir actually said or asked me to look into this, I started looking into this, and we took into account 32 premaxillae of different size. We looked at their external morphology, we did their scanning electron microscopes, and also we looked at their bone histology. We made sections of this premaxilla, and along each of these sections, we studied their bone microstructure. So what we found is that when we started looking at their external morphology, the first thing we saw is that these are very rugose. They show sort of longitudinal striations of bones. And then along with that, there are many foramina in this premaxilla. And this foramina are actually these are the entry point of neurovascular canals, that is through which arteries, veins, and all this type of grooves are present, which actually implies that there were arteries and veins present. So this sort of foramina are also present in the premaxilla. Then we look through ACM, that they are scanning electron microscope. Under scanning electron microscope, we found that this premaxilla, it has numerous foramina, numerous small holes in them. All are full of these holes. And when we started looking at them, especially when we started looking at the side view, we saw that many of them are actually parallel to each other. It's parallel to the premaxillary length, and it is parallel to each other. So then we started looking at the bone microanatomy. When we started looking at the bone microanatomy, what we found is that if these are the sections of those premaxilla, what we see is that these are very dense. There is usually, if you cut a bone, what you will find is in the middle is the medullary cavity surrounded by the bone material. In this case, that does not exist. Whatever you see in the outer part, whatever you see in the inner part, it's completely dense. And go back. Yeah, what we see also that in between these are the openings of blood vessels or the vascular channels, and in between there are actually lots of fibers present. It's a very fibrous bone. Next. So irrespective of whether this premaxilla is small in size or large in size, we see that they are very dense. And if I look at this in higher magnification, again we see next that it's fibrous. It's very much fibrous. And if I look at this end, this is the lower part of the premaxilla, we find that this bone is very irregular. It's very irregular. It does not, compared to all these parts, it does not have any smooth line. It does not have a smooth periphery. So again, we looked at this part of that another premaxilla. What we find is that at higher magnification, these are called frayed margins. What is the meaning of frayed margins? All these are actually vascular canals. These are the blood vessels. So these blood vessels are opening towards the outer side. Now, where is this blood vessel going? If this is an exposed bone, it does not have any covering, then where is this open blood vessels going? It cannot be that the premaxilla was bleeding continuously. That's the most improbable suggestion. So there has to be, the blood vessels are there to carry nutrients. So there has to be some sort of a covering over the premaxilla. And this type of covering, this type of bone microstructure is also found in the present day oxes, in the horns of the present day oxes in buffaloes, where they have this sort of frayed margin, because the buffalo horns, they are covered with keratinized epithelium. That is a very thick skin that they have. And similarly, so from all their studies, from the scanning electron microscopy, from bone microanatomy, what we found is that they had neurovascular foramina. Neurovascular foramina means they help to have a heightened sensory capability. Then they have profuse vascular channels that runs parallel to the long axis of the premaxilla. The bone is very dense. There is no distinction between the inner and outer area. They have a high vascularity and they have frayed margins. So from all these evidences, what we suggested is that these bones show pachyosteoclerosis. Pachyosteoclerosis means that the bone becomes very dense, very compact, because it has certain function. It has to do certain function. That's why it's so compact. And along with that, it had enhanced nutrient supply. That is, it has lots of numerous blood vessels are passing through this premaxilla, and because of that, it has a covering which is known as an integument or a rhamphotheca, which is actually present in the present-day birds. The beak of present-day birds, they are actually covered by this sort of integuments. And this sort of rhamphotheca is known also in many dinosaurs, in hadrosaurid dinosaurs. This rhamphotheca has been found preserved. So if you come to, this is the premaxilla, there are two premaxilla we are seeing, and this possibly is the rhamphotheca that is covering the premaxilla. Now next the question comes, why then what is the function of premaxilla? If this is not exposed, if this is not used as the tusk of crocodiles, elephants, like the elephants use their tusk, then what is the function? So is it used for digging for roots and trees? It cannot be, because for digging, again, if I think about the elephants, the tusk that they use, the tusk is actually made up of tooth material. It's made up of dentin, it has an inner pulp cavity, dentin and enamel. In this case, it is bone, and that bone has numerous blood vessels. So if it uses, or if it starts digging with this bone, then obviously that will cause stress, that will cause pain. So this bone cannot have been used for digging. And because of all this features that were present, and there is also another thing that we found is that wherever rhynchosaurs are preserved as fossils, nearby we find unionate bivalves. The fossils of bivalves are always near rhynchosaurs. So what we actually suggested is that this rhynchosaurs, they had the capability of probing in shallow water. By probing in shallow water at the sediment water interface to catch hold of the bivalves, to catch hold of the mussels. And mussels probably form one of its primary food source. So this is again, so far in previous studies, rhynchosaurs has been considered only as herbivores, because one of the main features that the scientists believe is that they use the premaxilla for digging. So now we are actually discarding that view. We are saying that no, they cannot have used this premaxilla for digging, but since these premaxilla have a sensory capability, that was used for finding out the mussels that is preserved, that lives in the shallow water. So this is one such study, paleobiological study. And in the next one, and the last topic that I'll be discussing about, is the reconstruction of the paleo ecosystem. Now, reconstruction of paleo ecosystem, if I try to do, obviously, I will have to take into account all different types of fossils. We cannot only take into account just the vertebrates and say that, yeah, this is the paleo ecosystem. For this, we need to take into account all the different types of fossils, be it plant fossils, be it trace fossils, be it in bivalves, whatever is preserved in that area. So basically, here I will be discussing, it's not possible because of time constraints to discuss all the fossil types, but along with the vertebrate microfossils, I will be discussing about the, macrofossils, I will be discussing about the microfossils and the trace fossils. So when we talk about vertebrate microfossils, what are they? These may be single animal, this may be parts of an animal or a skeleton, but their bones, teeth, and scales, the longitudinal axis should be less than 12.5 millimeters. So if you look at this collection of fossils, and if you look at the scale over here, it is 2 millimeters. So there's a very small size, different types of teeth, different types of skeletal parts that has been collected from the Tiki Formation, and more than 2,000 specimens have been collected, of which 1400 are of different types of tick. And all this has been identified. Some of them belongs to freshwater sharks, different groups of freshwater sharks. Some of them belongs to bony fishes. Some of them belongs to tetrapods or land animals. So all these are the different types of fossils. And these are some of the tick that has been collected. And this includes this 4 different types of freshwater sharks that has been discovered from the Tiki Formation. These are very small in size, very similar to that of the present day piranha. And these are also some types of bony fishes, the Osteichthyes. And these are the 2 types. One is the slung fishes, and then we have also the actinopterygians or the bony fishes, another type of bony fish. Then these are the teeth of different types of reptiles. There are 12 taxa has been discovered from this teeth, including that of a Saurischian dinosaur. And we also found some rhynchocephalians. Rhynchocephalians are lizard-like extinct group of lizards. So their teeth has also been preserved. And we also found the cynodont. Cynodont is a group that ultimately gave rise to the mammals. So there are also different types of molar and premolar teeth has been found. And so if I look at the Tiki vertebrate fauna, these are all the microfossils that has been reported from the Tiki Formation. These are the macrofossils that has been reported. Now, the yellow ones are the ones that has been recently established from the work that has been done with ISI by IIT Kharagpur. This includes, and all of them together includes nearly 30 new taxa. So quite a lot of information has come out in the recent years. And what we see is that this chondrichthyes are the freshwater sharks. This Osteichthyes are the bony fishes that are very similar to that of the present day fishes we see in the market. So these are the ones that actually dominated the aquatic realm or the aquatic domain of the Tiki habitat, whereas the amphibians, this Metaposaurids, are sometimes considered as fully aquatic, sometimes as semi-aquatic. So they are in sort of an intermediate group, along with the phytosaurs, which are, since they are crocodile-like, they occupy the semi-aquatic habitat, and all the rest belong to the terrestrial habitat, that is, they are the land vertebrates. So again, it shows the rarefaction curve that shows that the previous study, the curve was for Tiki was like this. Now with the discovery of this new forms, we have actually found the curve to have enriched quite a lot. So this is about the Triassic microvertebrates of Tiki Formation. Next, I come to the trace fossil in the form of coprolites. Now, coprolites are the fossil excreta. These were also collected from the same bone bed from where these vertebrate macrofossils were collected. And more than 400 of these coprolites were collected. These are actually identified based on their morphology, and it's very easy to identify them in the field. And what we found is that all these coprolites, they were bone bearing. That is, they had bone in there as inclusions, as undigested food. So what we find is that there are 3 different types are known. One is the scroll coprolite, where the scrolling means there is a sort of the scroll coprolite and spiral coprolite, what they have is along the longitudinal axis, because of the shape of the intestine, when this coprolites, they show a sort of a spiraling. So this spiraling in case of scroll coprolite is like that of if you roll a sheet of paper. When you roll a sheet of paper, it looks like a scroll coprolite. In case of spiral coprolite, the spiraling goes in this way. And there is also another group where we don't see any type of spiraling. But all of these are cylindrical. They have a very distinct morphology. And no, the other one. So these are the field occurrence of coprolites. Sometimes they are randomly preserved. You can actually make them out in the red mudstone. Sometimes they are aligned along the crossbeds. So, and sometimes they are actually found along with the unionids or the bivalve fossils that I was talking about. And the first group that I'll be talking about in a very short way is the scroll coprolite. Incidentally, the scroll coprolite, as I told you, it shows a rolling in the form of a news. If you roll a newspaper, you get this type of coiling. And this scroll coprolite was known from the Paleozoic. It was known in the Tertiary, but this is the first report of scroll coprolites from the Mesozoic. All over the world. So this was the first we reported the scroll coprolites from the Mesozoic. And if you make the sections, what you see is that because of the spiraling, all these bone inclusions, they also show a sort of a spiraling. This is another type. This is the spiral coprolites. Here also, these two ichnotaxons were identified. In this type, you see this type of spiraling. Then in the section, this is what we look like. It's a longitudinal section has been made. And all along this layers, all these layers, there are bone inclusions. Same you find over here also. They also show this type of bone inclusions present over here. Now to study what is the identity of these bone inclusions, we again took help of scanning electron microscopes. So, okay, and these are the non-spiral ones. In this, no, go back to the other one. In this, we don't see any type of coiling or anything. These are just cylindrical ones. But if you look at their external morphology, just you hold it in hand and you look at the surface, you will find this sort of bone inclusions in there. It's not only bones, there are different types of fish scales present, and there are many undigested particles present. So when we go for the ACM, what we find is that these are the fish scales. There are stacks of fish scales present. Some tooth is also present. This is the fish vertebra. Along with that, the other features we find are the desiccation cracks. Desiccation cracks means some of these coprolites have been actually exposed to air for a long time so that it has time to dry out. And then we also find the gas vesicles. These are again some of the inclusions. Here is an inclusion which we think is that of a cyanodon tooth because it's showing tooth differentiation. And these are stacks of fish scales present. Many undigested food particles in the form of skeletons are present over here. So based on whatever the fauna we had seen in the Tiki, along with the inclusions that we found in the coprolites, along with its morphology, because we know that the spiraling is something that is only found in fishes. It's not found in tetrapods, and this spiraling is again because of the intestinal morphology. It's not an arbitrary thing, but it is because of the intestinal morphology of fishes, this sort of spiraling is present. So what we found is that the scroll coprolites, they were produced by this Haberon sharks, that is the freshwater sharks. There were two genera present in Tiki, and these two produced this scroll coprolites. The spiral coprolites were again produced by other types of bony fishes. This Revocopros is another type of spiral coprolite that is produced by xenacanthic sharks. And the non-spiral coprolites, they actually, because they do not have any spiraling, but they do have cylindrical shape. That means that they get produced by tetrapods, or that is the land vertebrates. So many morphotypes have been identified, and for each of these morphotypes, we actually found what are the probable producers. So phytosaurs, metaposaurs, dinosauriforms, different types of carnivores which we could not identify, they actually produce this non-spiral coprolites. So once we know what are the coprolites, or once we know who produced the coprolites, it became very easy to reconstruct the predator-prey relationship in the tick ecosystem. So if I look at the tick ecosystem, based on whatever we have studied, what we found is that in the aquatic, if you look at this, is the probable interaction is given by dotted lines, and confirmed interaction is given by this solid line. So in the aquatic realm, this is the sort of interaction that has been going on between the different groups of fishes. In case of semi-aquatic habitat, we have the phytosaurs. In case of terrestrial habitat, we have those tetrapods. But what is characteristic of this predator-prey relationship is that all these habitats, they are not exclusive, but they are interconnected. That is, this habitat, the animals of this habitat and the animals of this habitat, they interact amongst themselves. So there is a food, if I try to draw the food pyramid, this is the food pyramid which Debarati and I made in 2012. Obviously, when we have just started working on the tick formation, but later with subsequent discovery, these are the different types of animals which we could add to this food pyramid. And the phytosaurs, obviously, at that time we thought that there were parasites present, but recently we know that the semi-aquatic domain is it has volcanofucus and polycyclicus. So this was the food pyramid that now it stands in this way. And this last slide is just a schematic representation of what the ticky ecosystem looked like. Because from sedimentological evidence, we know that the ticky sediments were deposited with fluvial sediments. It has an extensive floodplain. It has rivers that are surrounded by these floodplains, and there were dynamic animal communities that interacted with each other and that inhabited this floodplain and the rivers. If you look at the rivers, these are the different types of animals that inhabited the rivers. Along with that, and we also actually studied the plant fossils, but that I am not discussing here, so that we could get a ecosystem like this. So this is what my talk is about. And last but not the least, I should acknowledge my mentors, Professor Shashwati Bandyopadhyay, Professor Kapur Rajendri, and Professor Anusha Chinsami, for giving me the platform to work on vertebrate paleontology and the different funding bodies, and definitely to the West Bengal Academy of Science and Technology for honoring me with the first Sarbani Patranabis Deb lecture. And last but not the least, I am grateful to my students from whom I am learning every day. Thank you.
Yes.
Phytosaurs, you mentioned that they are primarily carnivores, but the etymology of the term phyto.
Yes, when they first found the skull, it was found in the 18th century, and when they first found, the scientist of that time, he thought that these were herbivores, and that's why he named it as phytosaurs. But later we found from tooth morphology, with more advancement of science, we found that no, these were actually ambush predators. And these were carnivorous animals.
And also another thing that you were mentioning about some epidemic disease, which
Yes.
was the cause of the.
Yes.
And also in some of the previous slides, you showed that there's a, it's some signature of the bone damage, asymmetric bone damage. Only one part of the bone is damaged and not the other part, something like that.
Bone damage?
The bone structure. If you just study the bone structure of the fossil,
Yes.
so you showed something that the one part of the
Yes.
bone gets
Yes,
affected,
yes,
but not the other.
yes. Yes.
So if that is the consequence of that, the epidemic disease, so there should be a correlation.
Actually, those, when we actually started looking into this, what we found is that in many of those preserved limb bones, one end is, it's lost. Yes. So again, we started looking at why is this the case? So we found that in waterlogged condition, many times the soft bone, that is the cancellous bone, that decays out.
Okay.
And this disease, what we are finding, that is from other parts of the
Okay.
skeleton.
That may not have.
That may not have been this. But this disease is very peculiar in the sense it has affected many of the individuals, but we still don't know whether this disease has resulted in their death. Because there is, at present, we have not found any indication of any lesion or anything on the surface.
And also whether the same disease affected any other species or.
Yes, that also.
Why
we need to
only-
look at. Why
Why
only
only
this?
this particular?
Yes.
আমার একটা প্রশ্ন আছে, আমি বাংলায় করবো। আমি বহু দূরে তো নাম টাম গুলো মনে নেই। আপনি একটা প্রাণী দেখালেন যে থেকে আপনি কন্ট্রোল করলেন তো মাসল কোনো খায়, তো সেটার জন্য আপনি দেখালেন যে ওদের ওখানে নার্ভের শুধু মাসল খায় কি করে সেই সিদ্ধান্ত?
না, not only muscle, আমি ওটা বলছি যে ওই যে
থাকে তো কি বলবো, জলা জায়গায় থাকে না,
জলা জায়গায় থাকে,
জলা জায়গায়
জলা জায়গায় থাকে, কিন্তু আমরা দেখেছি যে যেখানে যেখানে এর ফসিল পাওয়া গেছে এই অ্যানিমালটার, সেখানে সেখানে এই মাসল গুলো ফসিল পাওয়া গেছে।
আচ্ছা, ওই জন্য ঠিক আছে।
Yeah, that question.
I think আমার একটা প্রশ্ন, কোন প্রেজেন্টে মডেল আছে that you depicted for the tiki?
What?
Present model
For tiki?
for tiki.
Amazon
Amazon.
platform.
Amazon, not the Amazon.
Sir, general एक আমি বলছি Amazon platform.
Thank you, Professor Rick, for such a beautiful talk. Now I request Professor Shomnath Dashgupta to deliver a vote of thanks. Okay, sorry.
Thank you so much. So, thank you very much, Mitra, for a wonderful talk. It's a fitting tribute to Sarbani. And also, before I give the official vote of thanks, so I request Professor Shivaji Chakraborty, President WAS, to hand over a small memento as a token of appreciation for delivering this talk and for taking all the trouble to travel from Kharagpur for this. So,
No, coming back.
this is also a photo of Thank you very much, Professor Rai. And so now I have to give a formal vote of thanks. So for that, I have to read out the names, basically. So our heartfelt thanks go to WAST for organizing this lecture at ISI Kolkata. We'd also like to express our appreciation to the director of the institute, the dean of studies, and the professor in charge, who is incidentally here, sitting on the back. But thanks very much. Additionally, we are very grateful to the soft computing unit for providing this seminar room. Our thanks are also due to the security unit, the audiovisual unit, the CSSC unit, and the estate unit for their invaluable support in facilitating the lecture. And finally, I would wish all the best for the audience and thank all the audience, all the research scholars, and of course, like any other event, research scholars take the main burden to organize, and which they did, I think, quite well. So thank you very much, all the research scholars, and thanks to all the audience. Thank you very much, and I understand that there is some small refreshment outside. Okay, so we are happy to report that the live transmission of this particular lecture went on very well, and people could watch clearly, so they reported back to the president. Anyway, thank you very much, and now please enjoy some small snacks. Thank you.
You